The second law of thermodynamics states that the total change in entropy of an isolated system with time will never be negative. In other words, the entropy of an isolated system will never spontaneously decrease on its own. Now this has many implications, and I'm going to look at just a couple examples that hopefully make it clear what the meaning of the second law of thermodynamics is. The first example I'll give is the burning of fuel in an engine. Octane has the chemical formula C8H18, which simply means that it is a long chain of hydrocarbons. There's a long chain of 8 carbons in a row. There's a long chain of 8 carbons and 18 hydrogens around the chain. Now there's a lot of energy that's packed into this molecule. And the burning of the molecule releases that energy. The fuel wants to react with oxygen in a burning reaction, releasing a lot of energy. So right now, it could be said that the fuel is in a very ordered state. But when the reaction takes place and it burns, it becomes more disordered. So at first we have very ordered energy in this fuel. Then that fuel is placed in an engine where the reaction takes place. What happens is, energy flows out from the fuel, but into 2 different forms. Work and heat. So even though some of the energy is used to perform useful work to drive the car, a lot of the energy gets wasted as heat flow. And what this does is it increases the overall entropy of the universe. Another analogy that is often given for this is cleaning a bedroom. We all know that over time, bedrooms tend to get disordered unless you maintain them. If you do work to organize your bedroom, then what you're doing is you're changing the entropy. You're causing the entropy to decrease. But in doing this work, you also create a lot of friction between the soles of your feet and the ground. A lot of heat flows out of your body as you do the work as well. And the consequence of that is that the entropy of the surroundings goes up. But that alone is not the meaning of the second law of thermodynamics. What the second law implies is that when you decrease the entropy of the bedroom, the entropy of the surroundings has to increase by at least that same amount. If it was a perfect world, then you could increase the surroundings' entropy by exactly the same amount that you decrease the bedroom. But in reality, that never happens. In reality, the entropy of the surroundings will increase more. So what does this have to do with an automobile engine? In an engine, you take some of the energy from a stored source such as octane. Some of that energy gets used to do useful work, but the rest of it flows to the environment as wasted heat. And whenever an engine operates, what we find is that there's no such thing as a perfectly efficient engine. Some energy will always be lost to the environment, and that energy will always be used to increase the entropy of the universe.